Hi, today I will be completing a spectrophotometry simulation for my AP Chemistry class. The purpose of this experiment is to use spectrophotometry and Beer's law to find the concentration of the unknown drink. With this, we make a calibration curve from the concentration, which are already known. We find the unknown drink sample concentrations from its absorbance. A quick summary is spectrophotometry is a technique used to determine how much light a substance absorbs so its concentration or identity can be determined. In the simulation, the dye stock blue absorbed light at a specific wavelength, making it suitable for our analysis. By creating several standard solutions with known concentrations, it became evident that higher amounts of dye blocked more light, resulting in greater absorption readings. These values were then used to construct a calibration curve that illustrates Beer's law. The straight line relationship confirmed that absorbance increases in direct proportion to concentration, showing that the dye behaves consistently when interacting with light. Once this pattern was established using the standards, the same process was applied to an unknown beverage sample. Because the unknown's absorbance fit onto the calibration line, its concentration could be calculated using the slope from the graph. Overall, this experiment shows that spectrophotometry is a reliable method for determining the concentration of substances and determines the connection between light absorption and chemical analysis. So now we're going to start the dilution series. I prepared the series of test tubes with different dilutions. So here we have 10/2, 8/2, 6/4, 4/6, 2/8, up to nothing, which is basically our blank substance. The purpose of these dilutions is to create solutions with known concentrations. These known values will allow me to build a calibration curve based on Beer's law. Our graph will be shown here down below. So to begin, we're going to grab our pipette and we're going to grab some dye, and then we're going to place it in the 8/2. Okay, because we have less value from here, we're going to grab distilled water and place it in the tube. As you can see, we're going to perform the same steps over and over again. So you're going to grab your pipette, go into the dye, place it in your next tube, and then grab water, and then place it again. And once again, you're going to perform the same steps. Each time we're grabbing less and less of the dye and putting more water. And for our final tube, our blank one, it's just going to have water. Okay, so let's start. We're going to grab some from the blank and we're going to place it in our cuvette. And basically the purpose of this blank one it's our zero of the whole lab. This is going to ensure that the spectrophotometer ignores any absorption caused by the cuvette or the water and only measures the dye. So, as you remember, each time we grabbed less and less of the dye. So instead of the water, the spectrophotometry is going to focus on only the dye. So now we're going to place it into the spectrophotometer. And because we placed our blank, we're going to zero it. So we're basically balancing it, okay? That's going to be our baseline. Now we're going to discard of this. Okay. And now we have to rinse it to make sure there's no cross-contamination of anything. So we're just going to grab water, put in our cuvette, and now we're going to begin our lab, if you say. We're going to grab it from our first test tube and place it into our clean cuvette. And now we're going to place this again. Instead of clicking measure, instead of clicking 0, we're going to click measure. See, now we have placed our first dot on our graph, which is 49. Now we're going to discard and we're going to do the same steps all over again, each time making sure we rinse our cuvette and discarding of it. Here we click measure again with our second test tube and then discard of it. As you can see, each time you're going to place it and measure it, your graph will show a new dot on on the line. So now we're going to rinse. Oops. Once again, we are just rinsing to make sure none of the dyes get cross-contaminated. Make sure you're clicking measure each time and that your dots are appearing on your graph. Okay, because of our blank substance, our last one, it's going to have less than the rest of the tubes. And now we're going to place it in the spectrometer. Okay, so this should be our baseline once again, and it should be 100%. And because it is, we're just going to throw it away. And now we're going to clean it off for the last time. So now we're going to begin with the unknown drink sample we're trying to determine. So we're going to grab 3 millimeters of it, and we're going to place it in our cuvette like we have done, and once again place it in the spect, and we're going to measure it, and we have finished our analysis. Okay, so now we're going to use the slope of the calibration line over here to calculate the concentration of blue dye in the unknown drink. The purpose of this step is to apply Beer's law to find a real unknown value based on the known data I generated earlier. Here we have our solutions, our dilution, concentration, measured percentage, transmittance, and we have it in our decimal form and our absorbance. So my measured percent of T will range from 49% to the highest concentration, which is 87 if we don't consider our blank, because that's just our baseline basically. So it will range from 49 to 80% for the most diluted sample. So we're going to convert this into decimals by dividing it by 100, and then we calculate the absorbance. So this is going to range from our highest, which is 2.5, which is the most diluted. So we're going to plot this in our calibration curve. So we see how the graph is linear. This confirms the Beer's law. The slope of our line is 0.1358 absorptions per concentration. We're then going to measure the percent transmission over here of our unknown drink sample. It measures 39, and when we convert it into our decimals, it's 0.39. So to be able to find the concentration, we have to apply the absorbance of the unknown to the calibration line equation, which is using the relationship. So to equal concentration, the absorbance divided by slope is 0.4089 divided by 0.1358. So we calculate the concentration to be 3.011. Overall, by completing all steps, we show that spectrophotometry can accurately determine how much dye is in a solution. The experiment proves that absorbance increases with concentration and that the calibration curve can be used to find unknown amounts of the substance. Thank you so much for watching, and I hope this video was able to explain spectrophotometry simulation using Beer's law.